Okay, Pythagorean theorem is a squared plus b squared equals c squared, like it was in middle school. We learned on Thursday that if you see 3 and 4 as your legs, 5 would be your hypotenuse. 3, 4, 5 is a Pythagorean triple, okay? Now, here's the deal. If you don't memorize all these triples, by the way, these were the triples from Thursday. 3, 4, 5 is a triple. 5, 12, 13 is a triple. 7, 24, 25 is a triple. 8, 15, and 17. Those 4 different combinations give you perfect numbers. No square root signs, no decimals, perfect numbers, just whole numbers, right? And we learned if you multiply them by a number, like 3, 4, 5, if you multiply them by 2, 6, 8, 10, that also works. Multiply by 3, 9, 12, 15. Okay, so this was an exercise in identifying triples and going from there. Okay, so that's why on number 1 I can see, hey, it's 3, 4, 5 is a triple. The only way triples will help you is if you memorize them. Is anyone going to memorize these? You can. It'd be smart, because then you can take some shortcuts sometimes. But let's say you don't memorize them. What would you do? You would set this up as a squared plus b squared equals c squared. Now we said a and b are called the what? Starts with an L. The legs. And they're next to 90. So what 2 numbers are next to 90 here? 3 and 4. So I like to label a and b is my legs. And then c is across from 90. It's the longest side. And we call that the what? Hypotenuse. You know that? Okay. So you would have done 3 squared plus 4 squared equals c squared or x squared. Doesn't matter. Okay. Could you have solved that? Okay. 3 squared is 9. 4 squared is 16. What's 9 plus 16? 25. Now, everyone look right here. I need everyone's full undivided attention, okay? To get rid of this square, you have to do a square root. Cool? So I square root this side, cancels it out. And do we know the square root of 25? By golly, it's 5, right? So there's a reason why 3, 4, 5 works. So if you don't have it memorized, at least you could still do Pythagorean theorem. But I'm telling you, having to do this every single time, if you just know 3, 4, 5, you're good, okay? Now, number 2, we don't know this one. It's not a triple, so let's try this. I want to label my legs, A and B. So, here's my A, here's my B. They're both next to 90. And C is across from 90. C is going to be the measure of 9, right? So, I'm going to write my formula, A squared plus B squared equals C squared, okay? So, let's write that down, right? A squared, B squared, C squared. So, what's my A value? 5. B is, we'll call it X, and then C is 9. Now, do you have to use X? No, you can use whatever letter you want, honestly. 5 squared plus X squared equals 9 squared. Now, a lot of people mess this up by setting it up wrong. Some people will put 5 squared plus 9 squared. You don't always put the 2 numbers next to each other. It's always A and B that you're adding up, squared. Okay, what's 5 squared? 5 times 5. 25. Plus X squared, bless you, equals 9 squared. 9 times 9, 81. Does everyone see how I'm doing this? Everyone, right? Because that's how I want you to set it up, right? You write it out, and then to get X by itself, I have to get rid of 25. How do I get rid of a 25 there? You know what to do? Subtract to get rid of the 25. So minus 25, minus 25. What's 81 minus 25? 56. Okay. Last step. To get rid of a square, I use the square root. Did you know that? You did? Well, now you know. To get rid of a square, you do square root. So, now, here's the question. What's the square root of 56? Some of y'all will want to type it in the calculator. But remember last week, Monday, Tuesday, Wednesday, what were we doing with those square root signs? Breaking them down into factor trees, right? So guess what I want you to do? There's a reason why I taught it to you in that order. I want you to do the factor tree of 56. Now this one's not that bad, so let's try it. Square root of 56, it's even, so yeah, 2 times 28. That's even. So 28 is even, so it's 2 times what? 14. 14 is even, so it's 2 times 7. Okay? So is that, y'all remember that from Monday through Wednesday, last week? Breaking it down, factor tree. And when we break it down, these numbers go away. So, do I have any pairs? Yes. 1 pair of 2. And I got 2 loners. So does everyone remember? And if you're new, this is kind of what we did last week. But you factor tree, whatever you circle goes out of the square root sign. So the 2 that I circled goes out to the left. And then these 2 loners, 2 times 7, they multiply on the inside. 14. Yes. Okay, last part. Does everyone remember? A and B are next to 90. So 7 is A, 14 is B. So C is my hypotenuse that I'm missing. So we're going to do it the exact same way. I'll do this one in blue so you can see the difference here. So 7 squared plus what? 14 squared, right? So you see how the x sometimes is the C, sometimes the x is the B, sometimes the x is the A. Just depends, right? Okay. So 7 squared plus 14 squared. Now we can use our calculators to figure that out, right? So let's do that. 7 squared plus 14 squared. You can do it in one step. What do we get? 245 equals x squared. Now, I want you to tell me, how do I get rid of a square? Square root. Did you know that? Wow. All right, so here we do. Square root, square root. And then we're going to break it down. Does 2 go into 245? If it's odd, it does not look like it does. Let's try 3. Does 3 go into 245? Do y'all know how to tell if it does? Do 245 divided by 3? Right, so if it's not a decimal. So, or not a fraction. So 245 doesn't work. Let's try 5. Voila. So 245 is 5 times 49. And hopefully we know 49 breaks down into what and what? 7 times 7. So, what'd you say? Oh, so do we have a pair? Pair of 7, right? So 7 goes out to the left. Loner 5 stays in on the right. 7, square root sign, 5. And that's what we did Monday through Wednesday last week. So it's not going away. We're taking that radical stuff with Pythagorean and combining. Okay? Now, does everyone see right here? We're going to have a little quiz tomorrow over Pythagorean. I'm giving you an extra day to finish the Pythagorean assignment from Friday, and I want you to look at this. Okay, hold on, one second. Tomorrow's quiz is going to be just like this on the board. Not the same answers. So, look right here. Look at Mr. G. I'm behind you now. Over here. Next to the turn-in bin is a little review for the quiz. It's very similar to your quiz tomorrow. Very similar. All the answers for this are, look over here. Hey. Hey. These are the answers. And I have a YouTube video of me doing these answers to the review. And your quiz tomorrow is just like this. So it would be smart, if not now, tonight, at least watching it, at least trying it. Because tomorrow you have a quiz on this. everyone should know, because I just told you, and you have resources to help you review, but I want to make sure you've done 2 things prior to that. Did you turn in Wednesday's assignment on simplifying radicals? And did you turn in Friday's assignment on Pythagorean theorem? There's 2 assignments from last week and a review to do. So I'm giving you time. Nobody should be doing nothing. Everybody should be doing something mathematic for this class, okay? So I want to see that get done. If you are not sure what to do, seek help. We will help you, okay?